Okay, so this is the last bit of notes for joint variation, or for, I should say, for the variations portion of our functions unit. And this one's about joint variation and also about shortcuts. So, excuse me, joint variation, just going to dive right in here. Joint variation operates like direct variation, but it's a little bit different because instead of a constant and two variables, we have three variables. Crazy. All right, so the formula for joint variation, y equals k times x times z. All right, and again, just like in the others, k is the constant. So you know the drill here. The constant will always stay the same. We're going to use the first relationship to find the value of k, and then utilize k in the second relationship to find the value of the missing variable. So let's check out an example. If y varies jointly as x and z, so we've got y varying jointly as x and z, all right? And y equals 12 when x equals 9 and z equals 3. So there's our first relationship. Y is 12, x is 9, z is 3. And then in relationship number 2, we have a y value of 6 and an x value of 15, and we are looking for z. So this is number 1 and number 2. All right, so let's set up our formula using the values of relationship number 1 to solve for k. Whatever we're solving for has to be the only unknown variable. So y is 12, k is unknown, x is 9, and z is 3. So that means we've got 12 equals 9 times 3, 27. And if we're dividing by 27 and dividing by 27, then what are we going to get here? A cute little fraction, 4/9, right? Because we can reduce each of these by 3. 12 divided by 3 is 4. 27 divided by 3 is 9. So I've got this fraction of 4/9. Cool. All right, and now we're going to use that to set up the second formula. So y is 6, and I've got my k value of 4/9 times my x value of 15 and my unknown of z. So 4/9 times 15. What does that give us? I think we're going to wind up with a fraction. Let's see. 4/9 times 15 over 1. That's going to be 60 divided by 9. Does that happen evenly? No, it does not. And we can divide this down. We can reduce 60 over 9 to, let's see, 20 thirds. So we've got 6 equals 20 over 3 times z. So we're going to multiply that. To unstick it, we have to multiply this side as well. That means we've got z equals 18/20, which we can reduce down to, if we divide each of those by 2, we're going to get 9/10. So my value of z is 9/10. What a yucky example with all of those fractions. But you can see all we're doing here is multiplying. This couldn't be any easier. We're going to be given all of these values. We'll have one that we don't have, but this is just multiplying. There's nothing crazy. We're just plugging things in, and that's it. And you've got 3 variables with with x, z, and y instead of direct and inverse, only having the x and the y. You've got the z in there, really throwing in a curveball. All right, so let's try some identification. All right, this is going to be really important to understand, and you just have to commit this to memory. Sorry. You will need to be able to identify whether something is direct, inverse, or joint variation. So here's what we're going to look for. There's 2 different scenarios, and I've separated them here, scenario 1 and scenario 2. Very to the point, joint variation, you'll know it's joint because there's going to be 3 variables. That one's super easy to spot. It's 3 variables involved in a multiplication formula. Anytime you have addition or subtraction thrown in there, forget about it. We're not talking about anything. But if you spot 3 variables and it's all being multiplied or divided, then we're talking about joint variation. So there you go. There was our discussion about how to spot joint. But let's get back up here. For scenario number 1, when there is a variable by itself on one side of the equal sign, which is how we learned our formulas, right? It was always y equals blah, 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 blah on the other side. So when you see the formula in the way that you're used to seeing it with a variable by itself on one side, if a number is being multiplied by a variable on the other side of the equal sign. So let's just say, for sake of discussion, the variable is by itself on the left. If on the right side you have a number being multiplied by a variable, such as m equals negative 5p, you know that's direct. That's the same style as y equals k times x, right? Because k is a constant, it will always be a number when you're given an example like this and being asked to identify it. The number is always the constant. So if you've got a variable and a constant being multiplied by another variable, you know that's direct. Alternatively, if you have a number being divided, by a variable on the right side of the equal sign, such as r, a variable by itself, equals 9 over t, a number being divided by a variable, you know that that's inverse. It's the same thing as y equals k over x, which is what we learned. Okay, now here's where we're going to flip this around a little bit, because it's not always going to be as straightforward as a variable on one side by itself. Sometimes it might be a number on one side of the equal sign by itself, which we know means the constant. So if it's a number by itself on one side of the equal sign, then you have to rearrange what you have just drilled into your brain here. If you see a division problem, then you have direct. Direct, divide. Direct, divide. If and only if it's a number by itself on one side of the equal sign. Well, why is this? Isn't this inverse? If it's division, isn't it inverse? Well, no, not at all. If your constant is by itself, that means it had to get that way. So let's put it back to the way it was originally. We would multiply this side by d and multiply this side by d to cancel out that denominator, and we would be left with 14 times d equals p. Now this is the same thing as a variable on one side of the equation by itself and a number being multiplied by another variable. That is direct. And this is the same thing as what we were given here with 14 equals p divided by d. So that is direct. You have to pay attention to what is by itself on one side of the equal sign. If it's a variable, go for what you already know. Go for those formulas that you've drilled into your head already. If it's a number, then basically do the opposite of what you've been taught, okay? Direct is divide. So what does that mean for inverse? If you have a number by itself on one side of the equal sign, and then you see a multiplication problem on the other side, Then you have inverse. Here's my number, here's my multiplication. Well, why is that? What if we wanted to solve for one of these variables? We would have to, let's say, divide by s and divide this side by s. Now we have r equals 9 divided by s. This is inverse, right? This is the same thing as y equals k divided by x because the number is always the constant. So slightly confusing. Scenario number 1, it's what you've learned already. Scenario number 2, if there's a number on one side of the equal sign by itself, that is your constant. Direct means divide, inverse means multiply. Again, just memorize it and you'll be golden. All right, one last thing. Shortcuts. Everybody likes shortcuts, right? If you are not being asked to find the constant, if you're not being asked to find the value of k, then feel free to use the shortcuts. I'm not, unless I explicitly ask you, and some problems will, to list the value of the constant, then use these shortcuts. This makes it super simple and very quick. Your shortcut for direct, where your original formula is y equals k times x. So your shortcut for direct is x1 over x2 equals y1 over y2. So in this particular example, we are saying as if y varies directly as x and y equals 4 when x equals 12. So here's my first relationship. I know I'm going to have 12 on top and I'm going to have 4 on top. X is 12, y is 4. Find x when y is 10. Well, what do I do when I have a ratio set up like this? Everybody remember the butterfly cross multiplying? That means 120 equals 4x. Divide by 4, divide by 4. And we get x equals 30. Easy, right? For inverse, we're just going to multiply. If y varies inversely with x, y equals 10 when x equals 7. There's my first relationship. The best part about inverse is that you couple the relationships together. So those first set of numbers that you get to, multiply them together. Find y when x equals 5. There you go. 70 equals 5y. Divide by 5 and divide by 5, and you get, what, 14? 14 equals y. Didn't even have to mess around with finding k. Isn't that great? All right, joint. We've got y1 times z1 over x1, y2 times z2 over x2. So in my first relationship here, I've got y equals 5, z equals 4, and x equals 2. So we will have 5 times 4 divided by 2 equals, we're looking for y when z is 6 divided by 3. All right, so we've got 20 divided by 2 equals 6y divided by 3. Again, we can butterfly this, and that means we've got 60 equals 12y divide by 12, divide by 12, and we get 5 equals y. So those shortcuts are a huge time saver, especially if you've got a bunch of problems to do and you don't need to find the value of k. All right, if you have any questions, jot them down. We'll talk about it in class. We've got a couple days to review this as well as the midterm material. So don't be afraid to ask the questions that you have. That's the only way we're going to get to the answers, right? All right, guys, great job.